Factoring polynomials is thinking about them a whole different way, so we're going to take this pretty slow. The first kind of factoring you need to know is how to pull out a greatest common factor from each term. This is distributive property in reverse. So here's an example. When you look at this big long polynomial, check all the coefficients for common factors. These are the kind of numbers that you would reduce by if it was in a fraction. Negatives and positives don't matter for this, so let's just look at the numbers for factors. First, we look at the 8. 8 has factors of 2 and 4 and 8. Then look at the next one. 4 has factors of 2 and 4. So 4 is a common factor. So far, it's the greatest common factor. Next, we have 12. 12's factors are 2, 3, 4, 6, and 12. The largest one it has in common with 4 is 4. So far 4 is the greatest common factor. Does 4 go into 24? Yes. Does 4 go into 4? Yes. So 4 is the greatest common factor of the coefficients. Then you need to look at all the x's in the terms. Do all the terms have x as a factor? No. Look at this one. No x. If any of the terms don't have x, then x is not a common factor. So now what we're going to do is imagine that 4 has been distributed to all of these, and we're going to undistribute it. So we're going to divide all of them by 4, but we're going to rewrite it with the 4 out in front. This is not an equation, so we can't make the 4 just disappear. We can't divide both sides by 4. Now, since the first term is negative, I'd like to divide by -4 because it's nice to have the lead term be a positive number. So I'm going to just decide to divide everything by -4 because the first term is negative. If the first term was positive, I'd divide by +4. So we're going to rewrite this as -4 out in front of parentheses. And inside the parentheses, we write the polynomial that is left when you divide everything by -4. So in the first term, if you reduce by -4, you end up with a +2 here. So we have +2 x to the 4th. In the second term, we have nothing but 1 left, but it's a -1. In the third one, we have 3, but this turns into +3. And in the fourth term, we divide by -4, we get -6. And last of all, I have -1. So let's rewrite all of these. So -1x cubed plus 3x squared minus 6x minus 1. And now we have factored. This is -4, which is the biggest common factor that they all had, times the polynomial that's left. And this is what is meant by factoring. We have rewritten it as a multiplication problem of factors. Let's try the next one. There's only 2 terms, and we're looking for the greatest common factor. Since there's no x in the second term, the greatest common factor is just a number. It's the greatest common factor of 3 and 18. Think if it was a fraction like 3/18, what's the biggest number you could reduce by? That would be 3. So this is what we're going to divide out. So this is equal to 3 times what is left if you divide both of those by 3. So if I reduce this by 3, I would have x squared left. And if I reduce this by 3, I would have 6 left. Let's try one that has an x in every term. Okay, 4x squared minus 6x. The greatest common factor of this is going to be a product of a number and x. If you look at 4 and 6, the factor they have in common is 2. Now look at the x part. We have x squared and x to the 1. You just pick the lowest power that you see because it is a factor of everything else. Now we're going to divide everything by 2x to see what's left. So imagine dividing this by 2x, it reduces to 2x. And divide this by 2x, and we just have 3 left because the x's would cancel. And so this is the factored form. So the first step with factoring is to always check the polynomial for a greatest common factor and undistribute. We haven't even talked about what a trinomial is, but this is a hint right here, right? So it's a polynomial with 3 terms. And when you see a polynomial with 3 terms, they often factor into 2 binomials. I'm going to go backwards so you can see why this is true. Let's start with 2 binomials and multiply them. Right now, you're seeing the factored form. This is what answers will look like eventually. But let's start at the end and go forward. So remember that there's 4 multiplications you have to do. So x times x is x squared. Then we multiply x also by the second term in the second binomial. So x times 7 is 7x. Then you take the 5 and multiply it by everything. So 5 times x is 5x, and 5 times 7 is 35. Doesn't look like a trinomial yet, but remember this. This is going to be really important. These 2 terms are often like terms. Like every example so far has been like that. So we can rewrite it as x squared plus the sum of those is 12x plus 35. Imagine that I asked you to factor this. Well, when you look at those 3 terms, do you see any common factors? X is only in the first 2, and 12 and 35 don't have any common factors with 1. So you can't divide by a greatest common factor. Here's the second thing you look for. If it's a trinomial, can you turn it into the product of 2 binomials? Well, we know it's equal to x plus 5 times x plus 7, but how would we know that if we hadn't come from there? Let's see. If I give you a problem that starts right here, what are you going to do? Well, I do want you to check for a greatest common factor. There's nothing you can divide out in this problem. The next thing that you notice is it's a trinomial with x squared. We call that a quadratic expression. Go ahead and assume that we can make 2 binomials out of it, and then we'll see if it works or it doesn't work. How do we get the first term, x squared? It usually comes from x times x. We're going to just build those factors like it's a puzzle, okay? Now notice that when we multiplied that 5 times the 7, we got the last term. That is usually the case. So let's look at this number times this number. What are the possible ways you could get 35 for an answer? There's more than you might think. Don't forget, 1 times 35 is a possibility. And then, of course, 5 times 7. And since it's positive 35, it could also be negative 1 times negative 35 or negative 5 times negative 7. Those are all the possible products. So one of those has to work, and only one of them is going to produce this. Remember how we had a 7x and a 5x and they added together to give us 12x? So what we're thinking of is what 2 numbers give us a product of 35 but add up to 12. Do you see any like that over here? Look at all these examples. Here it is right here. 5 times 7 is 35, but 5 plus 7 is 12, which is that middle term we got from combining like terms. That's what I want you to look for in trinomials. Try to find what 2 factors of this number also add up to the middle number. And then you will know what these numbers must be. If they're positive, you put plus signs in here. If they're negative, you put minus signs. Then check and see if it really works. Since I got the same answer that I started out with, in this case, we know it really works. Now, your mind is probably blown right now if you've never seen this before. So you can back up and watch that again. It will make sense after you've seen more examples. The first example is always the hardest.